Week 1, June 23rd to June 28th, graphing ordered pairs, guided to go along with the video tutorial. When we look at coordinates for points, well, let's back up for a second. This is probably something that sometime a long time ago, somewhere in some math course, you have done before. So in that way, it is a review topic. However, it does come up as a new topic in Algebra 2, and for that reason, it is the first new topic, NEW, that we will be focusing on. That said, it is foundational in that it's going to be important, and everything in this chapter is going to build on it. So you will need this for everything else in this chapter to fall into place. This is also the chapter where you will need graph paper. So given that we are in a pandemic and it's not easy right now to just run out and grab something, nor am I suggesting it. If you can get on Amazon or somewhere else that is shipping and grab yourself some graph paper, that is going to be helpful because you're going to need it super quick, because if you're honest about this whole thing, this course is going to be over in the blink of an eye. At this point, I will even send you some graph paper if you really need it. Let me know if you can't get some or if you don't have access to a printer, because if you do have access to a printer, you will have access to the worksheets that will always have the graph paper coordinate plane on there, so graph paper won't be as much of a necessity. You could also, if you do have access to a printer, print that out. So that all said, if we look at this first part and the first question they ask us, what are the coordinates of the following points? Coordinates are basically expressed as an ordered pair. So if you think about what that means, if I ask you to go to Quick Check for me, my question should elicit a question from you. Which Quick Check? There's one in Lafayette, there's one in Sussex, there's one in Newton. You should not just get in your car and start blindly driving to a Quick Check without knowing which one it is. All right. Case in point, I have several times sent my husband to the wrong pizzeria or the wrong place after ordering food. That's by accident, obviously. Coordinates and ordered pairs act as a location or an address. So ordered pairs are expressed as an XY and they're expressed in parentheses. X always comes first, Y always comes second. X represents a left-right movement, and Y represents an up-down movement. There's always two movements, so you don't drop your point or place your point until you make those two moves. Even if one of those moves is 0, that still counts as a move. So when we look at this graph, okay, and we look at the XY axis, and you can kind of see, sometimes they'll put it there for you, sometimes they won't, okay. here they have it labeled, but you can't rely on them labeling it for you. You have to remember that the horizontal line is going to be your x-axis. The vertical line is going to be your y-axis. And if you think all movement happens from the middle, which is called your origin, we'll go over that a little bit later, but all movement happens from that middle point where the axes meet. And on your x, if you move to the right, it's a positive move, and if you move to the left, it's a negative move. If you move up, it's a positive move. If you move down, it's a negative move. All right, so that will give you a hint as to your signs. So when we are identifying an ordered pair, we want two numbers. We want an X and a Y. All right, and first we want to say how many did it move left, right. So if we're identifying A, which is right here, we want to go for the dot, not the letter. We always move again from that middle 0, 0 where the axes meet. So if I look, I didn't move any to the right or left because that point A is right above me. So that X coordinate is 0. And then I have to go up. So how many did I go up? 1, 2, 3, 4, 5, 6, 7. Because I went up, it's positive. I can write plus 7 if I want to. It's not going to get marked wrong, but just 7 is okay as well. All right, so if I look now, C. Again, I kind of make my template. I'm looking for two numbers, always in parentheses. And I'm all the way down here. There's my C. So again, starting at that middle where the axes meet, the origin, I know that I have to move to the right and then I have to move down. So how many do I need to move to the right? I have to move 2 to the right and then I have to move way down. So if you look, my movement is 2 and then down all this way. So if I count, I'm moving 2 to the right. That's going to come over here in my x coordinate. And then I'm moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down. Since I'm going down, I want negative 10. All right, let's do the same for D. Two number in parentheses template. D's over here. Moving from the origin, I'm moving to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left. And then I don't move any up or down. I'm on my dot, which makes it a 0. E. E's over here. So again, movement to E. From here, I'm going to move out to the left and then down. If I'm counting it out, and I want to count like boxes I'm moving, not lines. So I'm counting 1 box, 2 box, 3 box, 4 box, 5 box, right? And then down 1, 2, 3, 4, 5. So I moved 5 to the left and then 5 down. Left is a negative movement, down is a negative movement, right? So left is negative, right is positive, up is positive, down is negative. G. G's over here. If I kind of map my move, I'm going to the right and I'm going down. It's a mirror image of E, if you think about it that way. So I'm moving 1, 2, 3, 4, 5 to the right, positive, and then down 1, 2, 3, 4, 5 in the negative. So it's 5, negative 5. All right, graph the following points on the coordinate plane to the left. Be sure to label each point with the corresponding letter. So now I'm going to do the exact opposite. Now I have the points and I want to place them on my graph. So if I go through real quick, I know this is going to be my left, right, right? I know this is going to be my left, right. I know this is going to be my left, right. And I know this is going to be my left, right. If I want to get more specific, I know that that's actually not any movement because it's a 0. I know this is a negative, so I'm going to be moving to the left. I know that's a negative, so that I'm going to be moving to the left. And I know this is a positive, so I'm going to be moving to the right. If I look here, this is going to be up, down, up, down, up, down, up, down, not like the country song. All right. Again, because it's 0, there's no movement. This is 4, meaning it's up because it's positive. This is -4, so it's going to be moving down. And again, I have a 0 here, which means there's going to be no movement. So I've kind of mapped out what I'm doing. This no movement makes sense because this 0, 0, if you think about it, it's where these axes meet. I'm not going to move left, right, and I'm not going to move up, down. So basically, I'm staying at home. I'm staying put. So I mark that point here and I label it with a J. For K, I'm moving 2 to the left, -2, and then I'm moving 4 up. So I'm moving 2 to the left and 4 up. I don't want to mark my actual point until I stop, which places it there. 2 to the left, 4 up. For L, I'm moving 3 to the left and 4 down. So 3 to the left, 4 down. Okay, 3 to the left, then 4 down. And I'm marking my point and labeling it L. For M, I'm moving 5 to the right, and then I'm not moving at all, up or down. So again, I'm counting 5 to the right, and I'm not moving up or down, which is M. So I have J, K, L, and M. Now, down here at the bottom, when we want to name the quadrant or the axis that contains each point, we need to mark a little bit, label what happens and where things are found. So we've kind of talked about each of these things, but now let's label them specifically. So we talked about the origin happening in here where the axes meet. We've talked about the horizontal line being the x-axis. And we've talked about the vertical line being the y-axis. For the quadrants, we're going to start in the top right quadrant, and we're actually going to work counterclockwise, and we mark them with Roman numerals. So we start with 1, 2, 3, 4. Now, more specifically, if we don't want to map out and mark out every single one of these, we can look at, again, what we talked about. If we go to the right, we're positive. If we go up, we're positive. If we go left, we're negative. If we go down, we're negative. Which means that if we look at any ordered pair in the first quadrant, we go to the right and we go up, we're going to be positive, positive. If we're in the second quadrant, that means we went to the left and then we went up. So we are negative, positive. If we're in the third quadrant, that means we went to the left and then we went down. So we're negative, negative. And then if we're in the fourth quadrant, that means we went to the right and then we went down. Positive, negative. So knowing these things, we can name the quadrant or axes that these points are each a part of without really paying attention to the numbers, but paying attention to the signs. So if I look at this one, I have a positive number and then a negative number. Looking at my diagram there, which one of those quadrants is positive, negative? Well, that will always fall in the fourth quadrant. If you kind of draw your diagram to go along with that, okay, I have 7, negative 12. I went positive, then negative. It will be somewhere down here. Here I have positive, positive. So positive, positive will end up in the first quadrant. Again, drawing it out, not truly based on numbers, but just approximations. I'm going positive, positive. I'm going to be somewhere up here. It's really handy when we get to something like number 12 because look at those huge numbers. You're not going to want to sit there and count out 80 boxes. I look at the signs. I have a negative and then a positive. Negative and then a positive is quadrant 2. And again, I look at the approximation in my drawing or I sketch it out. I have a negative and then a positive, and it's somewhere over here. Now 13, I have a positive and then a 0, which is the first time we've seen something like this happen. Notice I don't have any zeros in any of the signed ordered pairs I drew over here in my diagram, which means it's probably going to be one of these special points, my origin or on an axis. If I draw out my sketch of what's happening, I'm going to the right 14 and then I'm not moving up or down, which means I am on an axis and the axis that I'm on is the x-axis. It doesn't fall in 2 quadrants. It can never fall in 2 quadrants. I am simply on one of the axes. This one is negative, positive, which again would fall in the second quadrant. My diagram would look something like that, which is very similar to number 12. And number 15, I have 0 and a positive, which I know that I'm looking at, again, one of these special ones that don't fall in a quadrant. They fall on an axis or an axis. Okay, and if I draw out what's happening, I'm going to not move left or right, but then I'm going to go up. And that means I'm going to be on the y-axis. And there you have it. Go back through if you got stuck or if you want to rewatch. And then when you're ready, go on to the week 1 graphing ordered pairs independent sheet, and you can check your answers with my answer key.